Hello friends, this is section 7.5, Proportions in Triangles. The essential question is, what kind of proportions can we make into triangles? Let's begin. So we got three theorems here. Side splitter theorem. That sounds like a car. Anyways, this theorem is if the line is parallel to one side of a triangle and intersects the other two sides, it divides those sides proportionally. So what's that saying in the English? This over this is proportional to this over this. That's all it's saying. Next one. Kind of a corollary to that. So if you have three parallel lines with two traversals, then the segments intercepted on the transversals are proportional. So what that's saying is this over this is proportional to this over this. That's what it says. Last one. Triangle angle bisector theorem. If a ray bisects an angle of a triangle, then it divides opposite sides into two segments that are proportional to the other two sides of the triangle. So AD is my bisector, and it cuts CAB into two congruent angles. So what this is saying is this over this is proportional to this over this. That's it. Just a bunch of proportions. So let's try some examples. Pause the video. Okay, what's the value of x in the diagram on the right? So I'll make some proportions. This over this equals this over this. And solve for x. So the first thing I'm going to do is multiply by 12 on both sides, so this is just going to come up, and multiply by 9 on both sides, so this is going to come up. So what that turns into 9 times x plus 1 equals 12 times x. If you need me to show you that in class, I will, or leave a comment. So distributing this, I'll get 9x plus 9 equals 12x. Subtract 9x on both sides, and I'll get 9 equals 3x. Divide by 3, and I get x equals 3. So there's my answer. Next one. Alright, 3 campsites is shown in the diagram. What's the length of site A along the river? I'm going to call that x. So we can make some proportions here. We've got parallel lines, and traversals is the lake shore, and this other side right here, the edge of this camps. So I can make some proportions. I can say this x over this 8 equals this 9 over this 7.2. So to get rid of these fractions, I can cross multiply here. That 8's going to the top, so I get, stop messing up, 9 times 8 and 7.2 times the x, so 7.2x. So 9 times 8 is going to be 72 equals 7.2x. Divide by 7.2 on both sides. You get x equals 10? Probably 10. That's your answer. Next one. Okay, so value of x in the diagram. So we got some proportions. That's that last one, the bisectors. So the way that works is this over this equals over and then we solve for x. So I'm going to move that x to the top and move that 10 to the bottom. So I get x over 12 equals 18 over 10. Multiply both sides by 12 and I get x equals 18 over 10 times 12. I'm going to start playing the cancel game. Divide both those by 2, left with 5 over 6. And that doesn't reduce anymore. So I'm left with x equals 5, and 6 times 8 is 48, carry a 4. So 108 over 5. That is the value for x. Am I right there? No, I'm not right. I messed up. Okay, do that again. It's 12 over 10 equals x over 18. That's what it should have been. So you multiply by 18 on both sides. And what happens there is I'm going to reduce this by 5, and this is going to be 9. So I am going to get, oh, maybe I was right. 108 over 5 equals x. I think that's the same thing. Okay, I was right. Oh well, not editing. Go.